Good evening, everyone. Okay, this is the sixth lecture for the subject Healthcare Innovation, SN5119. In this lecture, we will introduce one of the important topic in uh, healthcare innovation, medical image processing. Particularly, we will introduce some advanced deep learning models for medical image processing. Okay, as you know, deep learning is one of the hottest topic in computer science and engineering. Okay, it is a kind of AI technology, artificial intelligence technology. It is a very hot topic, okay, in recent years. Okay, before this lecture, we will make some important announcement, okay, of the subject. The first, please be reminded that the deadline of the first presentation is approaching. Okay, the deadline of the first presentation is on March 31. March 31. Okay, 11:59 p.m. So please remember, upload the file with the voice presentation in YouTube or send it to me by email before the due date. It's better you upload the file in YouTube and send me the website to access the video, the presentation file. Because as you know, the email usually has a size limitation. Okay, if you presentation file is too large, it's quite difficult to send it by email. In addition, if you upload the presentation file in YouTube, please keep it available at least to July 31 to facilitate our marking. In addition, there's another important thing. We shall replace the face-to-face written test with an individual reflection report because the university has informed us that we should cancel all face-to-face teaching and activities in this semester due to the coronavirus outbreak. So we have to cancel the written test and replace it by an individual reflection report according to the team project. That means everyone should write an individual reflection report, okay, based on the term project, okay, at the end of this semester. The specification of the report, individual report, will be released soon. Okay, just remember that we have to cancel the written test, okay, which carries around 30 marks of the whole subject. Okay, instead, we ask every student to submit an individual report, okay, at the end of this semester, okay. It carries these 30 marks. So here are the intended learning outcomes of this lecture. So in this lecture, first, we hope you can understand the fundamental concepts of medical image processing and the medical image representation. How a medical image be represented and stored in a computer. Okay, medical image representation. And second, we hope you can understand the main applications of medical image processing. Okay, the concept of main applications of medical image processing. In this lecture, we will focus on one of the applications, medical image segmentation. So I will introduce the key techniques for medical image segmentation. Then, as mentioned, we will introduce the basic concepts of deep learning, the basic concepts and principles of deep learning. And finally, we will introduce some advanced deep learning models for medical image segmentation. So first, let's introduce how a medical image represented or stored in a computer. Actually, in a computer, a medical image is represented and stored as a collection of measurements in 2-dimension or 3-dimension. Okay, whatever CT images, ultrasound images, or MR images. Okay, a collection of measurements Usually, we call this collection of measurements as intensities. Actually, different imaging modalities have different ways to measure the intensities. For example, in CT imaging, we use the radiation absorption to measure the intensities. As we know, different tissues may have different radiation absorption characteristics, so the different tissues exhibit different intensity in the CT images. Similarly, we can use acoustic pressure to measure the intensity value in ultrasound images. Similarly, we can also use the radio frequency signal amplitude to measure the intensity in MR images because different tissues have different radio frequency signal amplitude, okay, in ultrasound image. Another very important concept is pixel or voxel. So what is a pixel? What is a voxel? Actually, pixel or voxel is a discrete spatial location of finite size with a discrete grid level, okay, intensity. A discrete intensity is called a pixel. Okay, a pixel or voxel is a discrete spatial location. In 2D images, it is called a pixel. It is a pixel, 2D images, okay? Such a discrete spatial location is called a pixel. But in 3D images, such a small volume is called a voxel. Okay, it is a small volume with a finite size, okay? Actually, there are a lot of differences between the natural image processing and the medical image processing. Okay, there are a lot of differences. The main differences is that usually the natural images are color images. Okay, that means each image has 3 color channels: red, green, and blue. In such a case, each pixel has 3 intensity values. Okay, so the intensity at each pixel is the average value of the 3 channel values: the red value, the green intensity value, and blue intensity value. Okay. However, on the other hand, in medical images, the medical images has dominated by monochrome image modalities. Okay. In contrast, medical images are usually not color images. Okay, they are monochrome imaging modalities. So what does this mean? Okay, in a monochrome imaging modalities, each pixel or each voxel just has 1 channel, okay, 1 intensity value. Okay, it is used to evaluate how black or how white it is. Usually we call such a value gray level. Okay, it is a value between pure white and pure black. Okay, so we call it gray level. Surely there are some color images used in medical applications, okay, such as cervicography images, dermoscopy images, fundus photography images, gastrointestinal endoscopy images, microscopy images, wound photography images. But as I mentioned, in clinical practice, most medical images are monochrome imaging modalities. So in such a case, in this lecture, we focus on monochrome imaging modalities. That means each pixel has just 1 color channel. Okay, each pixel just has 1 intensity value. Okay, evaluate how black and how white the pixel is. The next important concept is intensity histogram. So it is one of the simplest yet most useful tool in medical image processing. So what is intensity histogram? Intensity histogram is a function showing for each grid level the number of pixels that have that grid level. Okay. In such a case, actually the intensity histogram is a kind of distribution of grid level in an image. Okay, demonstrates the distribution of grid level in each image. So this figure, okay, show the intensity histogram. Okay, you can see in the horizontal axis is a different grid levels, and the vertical axis is the number of pixels. So different grid levels has different number of pixels. Okay, that has that grid level. Remember that the intensity histogram is very important in medical image processing, a very important concept. It's very simple, but it's very important, okay, in medical image processing. Okay, then let's talk about one of the commonly used medical processing operations and methods, local operations. Local operations. So what is a local operation? In a local operation, the value of a pixel in the output image is a function of the corresponding pixel in the input image and its neighboring pixels. Usually we call these local operations as filters, image filters. So for example, one of the most commonly used filter is the mean filter. So what is a mean filter? In a mean filter, we replace the value of each pixel. By a weighted average of the pixels in some neighborhood around it. Okay, in 9 neighborhood or in 4 neighborhood. Okay, if all the weights are equal, then this is a mean filter. For example, these figures show two mean filters. Okay, in the first mean filter, okay, we use the average of the 9 neighborhood, okay, to calculate, okay, the average and replace the original intensity value with this average of the 9 neighboring pixels. Okay, the second mean filter just use the neighboring 4 pixels. Okay, we average the neighboring 4 neighboring pixels to replace the original pixel intensity value of the pixel. So these two mean filter. The mean filter is usually used to remove noise, okay, of this image and smooth the image by removing some artifacts or noises. Okay, the mean filter. The next commonly used filter is a median filter. Okay, different from the mean filter. Median filter replaces each pixel value by the median of its neighbors, not the mean of the neighbors, the median of neighbors. Okay, for example, the value such that 50% of the values in the neighborhood above and 50% of the values are below. But such a filter is difficult to and costly to implement, okay, in computer algorithms, because we need to sort the values, right? To calculate the median, we need to sort the values. Okay, here is an example. Okay, here is the neighborhood values of the pixel with the intensity value 150. Okay, there are 9 pixels. Okay, we should sort the 9 pixel and calculate the median value is 124. Then we use the 124 to replace the original value 150. Okay, so usually it's quite difficult and costly to implement because we need some sorting algorithms. Okay, however, one of the advantage of the median filter particularly compared with the mean filter, is that it is generally very good at preserving edges, okay, when removing the noises. Here is an example. This is an input image. Okay, there are a lot of noises, right? There are a lot of noises. After performing the median filter, this is the output image. Okay, you can see that remove the noises, make the image smoother. But on the other hand, simultaneously, we also well preserve the edges, right? The edges in the original image. Okay, so the advantage of media filter compared with mean filter is that, okay, when removing artifacts and noises, the median filter can better preserve the edges of original image. Okay, if you want to preserve the edges or some salient features, okay, it's better to use the median filter than mean filter. Well, both mean filter and median filter are low pass filters, okay, because they just use some linear operations, okay, among the neighboring pixels, such as the average and the median, okay. So there is another kind of filters called high pass filters. In a high pass filter, we assign different weights to different neighboring pixels in order to subtract contributions from neighboring pixels, resembles differentiation. And in such a way, we can emphasize or sharpen variations in contrast, okay, by assigning different weights to different pixels, neighboring pixels. So such a technique is called high pass filtering, okay. It is not just a linear operation, okay. The operation is a little bit complex, assigning different weights to different neighboring pixels. Usually, high-pass filtering is to make the image sharper. Okay, note that low-pass filtering is usually to make an image smoother. Okay, but the high-pass filter is to make the image sharper. So just the opposite of low-pass filtering. So in such a case, the high-pass filtering is usually used in some applications such as edge detection to detect the edge. But remember that while high-pass filtering can often improve an image by sharpening details, overdoing it can actually degrade the image quality significantly. So remember, do not overdo high-pass filters on an image. So here we show two commonly used high-pass filters, Sauber filter or Laplacian filter. Okay, you can see, okay, in high-pass filters we assign different weights to different neighboring pixel value. Okay, we assign different weight to different pixel value. So here is an example of a Sauber filter. You can see this is an input image, and this are a different output image of different Sauber filters. Okay, you can see that in the output images, the edges of the original image are obviously sharpened. Okay, so remember that the high-pass filtering is used to sharpen the edges or salient features. Okay, but on the other hand, the low pass filtering is usually used to smooth the image, to reduce the noises and artifacts. Actually, all above mentioned filters are spatial filters. But in some medical image processing tasks, it's quite difficult to just using the intensity, okay, spatial filter to handle. For example, in ultrasound images, there are a lot of uh, noises, so quite difficult to distinct the features, anatomical features, and the noise by just using the spatial filters, just based on intensity values. So usually we should use information from the frequency domain, okay, to handle some medical imaging processing tasks, okay. So what is a frequency methods? Frequency refers to the state of repetition of some periodical event in imaging. Spatial frequency refers to the variations of image brightness with position in space. Actually, a varying signal can be transformed into a series of simple periodic variations. Okay, so one of the most commonly used frequency methods is Fourier transform. Fourier transform, a very important and well-known frequency method. Okay, in Fourier transform, okay, we decompose the signal into a set of sine waves of different characteristics, okay, frequencies and phases. Okay, actually the Fourier transform plays a very significant role in medical image and image analysis. In principle, it is a linear transform that provides information about the frequency spectrum of a signal and is used in image processing for image enhancement, restoration, filtering, and feature extraction. So there are a lot of applications of Fourier transform. Okay, just remember the Fourier transform is a well-known and important frequency method for medical image processing. Okay, it uses the information extracted from the frequency domain, okay, to handle medical image processing tasks. Okay,